Good afternoon, this is Kavipriya, EC Department, SNS College of Technology. I am going to discuss about the topic Superposition theorem from the subject Circuit Analysis. First, we can see what is the statement for the superposition theorem. So, in any linear and bilateral network which has a multiple independent sources, the response of an element will be equal to the algebraic sum of the responses of that element by considering the one sources at a time. So, we will be calculating a response of the element by considering the only one sources at a time. So, the overall response of a circuit is equal to the sum of the individual responses. Next, we are going to see about what are all the guidelines that is involved in the superposition theorem. So, when you sum the individual contributions of each and every sources, first thing is important thing is that we have to assign the sign to the quantities that is available in the circuit. So, we have to follow a reference direction. If the contribution from the source has the same direction as that of a reference direction, then a positive sign is assigned. If it has an opposite direction, then the negative sign is assigned. All the components must be linear. So, the superposition theorem will be applied only to the linear elements. It should be noted that it can't be applied to calculate the power because the power is not a linear quantity. And next is how to apply the superposition theorem. The first step is to select one among the multiple sources that is present in the bilateral network. Among the various sources in the circuit, any one of the sources can be considered as the first. Except for the selected sources, all the sources will be replaced by the internal resistance. Using a network simplification approach, we can calculate what is a voltage that is available at a particular element or what is a current that is flowing through the particular element. The same considering a single source is repeated for all the sources that is available in the circuit. Upon obtaining the respective responses from the individual sources, we will be performing the summation of all the responses to find overall response of the particular circuit. So, it is the overall voltage drop or current through the circuit element. Next, we are going to apply the superposition theorem to an example to find what is the overall response of a circuit. So, in this circuit, we are going to find what is the current that is flowing through this 20 ohms resistor using the superposition theorem. The first step is that we have to find the current through this 20 ohm resistor, right? So, the currents in this case of superposition theorem, the voltage source can be short circuited and current source can be open circuited. So, after doing this such type of modification, the nodal voltage V1 can be determined by the nodal analysis method. So, nodal equation at node 1 is written as V1 minus 20 by 5 plus V1 by 10 plus V1 by 10 plus 20, which is equal to 0. After simplifying, we get the value of V1 as 12 volt. The current flowing through 20 ohm resistance can be calculated using the equation I1 is equal to V1 by 10 plus 20. By substituting the value of V1, we will be getting a current as 0.4 amps. So, therefore, the current flowing through this 20 ohm resistor due to 20 volt supply is taken as 0.4. Next step, we will be short circuiting the voltage source. In first step, we have open circuited the current source, and second step, we are going to short circuit the voltage source and we will be considering only the current source 4 amps. So, in the above circuit, this resistance 5 and 10 are parallel to each other and we have to apply the parallel combination. After applying the parallel combination, we get the value as 40 by 3 ohms. And after that, the current flowing through 20 ohm resistor can be determined using the current division principle. So, after applying the current division principle, we will be getting the current value as 1.6 ampere. So, in the first step we have got the current through 20 ohms resistor as 0.4 while considering the current source alone. In second step, the current through resistance 20 ohm is obtained as 1.6 by considering the voltage source. So, next we have to add both the response to get the overall response. So, we have to add the value of 0.4 and 1.6. We will be getting the answer as 2 ampere, which is a current that is flowing through 2 amp, which is a current that flows to the 20 ohms. Next, we are going to see about what are the limitations of superposition theorem. The theorem does not apply to the non-linear circuits. So the requisite of linearity indicates that superposition theorem is only applicable to determine the voltage and current but not the power. Power dissipation is a nonlinear function that does not be algebraically add to accurate the total when only one source is considered at a time. The application of superposition theorem requires two or more sources in a circuit. And next, what is the superposition theorem? The superposition theorem is one which is used to solve a network which has more than one sources present at that time. Is the superposition valid for AC circuit? Yes, the superposition is valid for AC circuits. Can superposition apply to nonlinear circuits? No, the superposition cannot be applied to the nonlinear circuits. And next, is the superposition theorem applicable to power? No, it is not applicable to power because power is a nonlinear quantity. And why do we use the superposition theorem? Because to analyze a complex circuit which has more than one sources, we go for the superposition theorem. So that's all about the superposition theorem. We have seen about what is the superposition theorem statement, and we have discussed about what are all the steps involved in superposition theorem, and next we have discussed about how to apply the superposition theorem, and we have seen one example, and finally we have discussed about the limitations of the superposition theorem, and finally we have seen certain assessment questions. Thank you.